I'm going to present 3 problems at one time because they're all fairly brief. So in this particular case, I'm going to do S71, 72, and 73, as you can see from the screen. In 7.1, we're asked to calculate the utilization rate. We simply take the actual output and divide it by the design capacity. As a reminder, the design capacity is everything is perfect. There's no flaws. There's nothing broken. The machine doesn't need to be cleaned or calibrated. It can operate at 100% of the time. So in this case, we have our hammers, and you actually make 6,000 hammers when it's possible. Under perfect or ideal conditions, you could make 7,000 hammers, and you can see you run at 85.7% utilization rate. So it is possible you could make more hammers, but usually utilization rates would say be in the low 90s would be considered to be good. Even anything in the 80s or certainly high 80s, just because you have machine breakdowns, etc. Now, in part S72, you're looking at efficiency. You're taking actual output and the effective capacity factors in machine being broken down, a classroom being cleaned, so it's not available to have an actual class in there. So things along that line. A machine needs oil to be changed every once in a while or recalibrated, on and on. So in this case, you made 4,500 hammers, and you could have made 6,500, so you're only using 69.2% efficiency, which would be considered low. Now, that's for making hammers. You can take some of that slack, and what you can do is you can make something else. So it's not always necessarily a bad thing. This is the efficiency for making hammers. Now, in S73, you want to find out what is the actual output. Well, the effective capacity is 6,500, and the efficiency is 88%. So all this is a rearranging of the formula from 7.2, but you get a different answer and you find out the actual output. So if the effective capacity is 6,500, as it is from part 7.2, and you actually have efficiency of 8,800, or 88%, sorry, you will actually make 5,720 hammers. So you just can take the effective capacity multiplied by the efficiency. A lot of organizations will definitely know their efficiency, and they certainly know their capacity. So they have a pretty good idea exactly what efficiency they have to run at to make that number of hammers. And that's all it is for 7.1, 7.2, and 7.3.